Lesson 6-5. Let's start with this question. Do you remember graphing inequalities such as x is greater than negative 1? I'm zooming in so you can see that that's actually an open circle. We had to show that this is an open circle because we're not including negative 1, and we had to show that we mean everything on this side of negative 1 because we want everything that's greater than negative 1. One way to describe this graph is by saying that it is one-dimensional. It only shows one direction. I wonder if we can show that same information but in a two-dimensional way. Well, if we can graph it on a Cartesian plane like this, that would turn it into 2 dimensions. So let's think about that. We know how to graph x is equal to negative 1. That would be a vertical line here, showing all the locations where x is equal to negative 1. But, well, with our inequality, right here, x is never equal to negative 1. So we come right up to, for example with this one, we come right up to where x is equal to negative 1, but we don't include it. So let's try it this way. If I draw a line right here, but I don't make it a solid line, I'm going to make it a dashed line. Look at that. Isn't that pretty? Okay, so I have created what's called a boundary line. Negative 1, x equal to negative 1 is right here. And I think that all the numbers on one side or the other of this will fit our inequality of x greater than negative 1. Well, which side? How can we figure that out? You know what we could do? We could test something. What if we tested with x is equal to 0? Because, oh, that makes the math so easy. So, is 0, remember we're dealing with, I should just rewrite our inequality down here. Remember we're dealing with x is greater than negative 1. Does 0 work as a solution for that? Is 0 greater than negative 1? Of course it is. Is 5 greater than negative 1? Yeah, it is. So both 0 and 5 work. What happens if we try something on this side of our dashed line? Does negative 4 work? Is negative 4 greater than negative 1? No, it isn't. So here's what we're going to do. It's very nice if you have a colored pencil. You can see I'm using a crayon, something other than the pencil that you've drawn the graph with. Any x value where you have colored in fits this graph, and I was shading very lightly. If I zoom in, you can see it better. So now we have created a two-dimensional graph of the inequality x is greater than negative 1. Here's one way to show this information, one-dimensionally. Here's what it looks like two-dimensionally. We had to create a boundary line at x is equal to negative 1. That was our first step. We had to make it a dashed line because it doesn't include negative 1. And then we had to figure out which side of that line has our solution. X is greater than -1, so we're over here. Did we answer both of these questions that I wrote down? How do we show the open circle? Well, we showed the open circle by using a dashed line. And does the single line show all of our options? No, it really doesn't, which is why we shaded in over here. What we just did is letter A of problem 3 on page 391. They want you to graph x is equal to -1 using a dashed line. Why? Because -1 is not part of our solution. Right there, there's our boundary line. Use 0, 0 as a test point to figure out which side of the line you're going to shade in. And since 0 is greater than -1, you're going to color that in. Take a look at letter B. If y is greater than or equal to 2, how are you going to graph that? Well, first step, graph y equals 2 using a solid line. Why do we use a solid line this time? Because 2 is part of our solution. You can always use 0, 0 as a test point, and you really only need one test point. The only time you can't use 0, 0 as a test point is if your line is going through it, but we'll get to that later. Let's see what this looks like. So we've got our solid boundary line at y equals 2. And then since 0 is not greater than or equal to 2, that means you need to shade the other side of the line. All right, it is your turn to try a couple of these out. So got it, number 3. Page 392, letter A and letter B. I want to see the graphs. So, letter A. First, it is a less than, not a less than or equal to, so you need a dashed boundary line. We're talking about all the locations where x is equal to -5 for the boundary line. So that's right there. Notice that it is dashed. Then, use your test. 0, 0. Is 0 less than -5? No, it isn't. So don't shade this side of the graph. Shade this side of the graph. If you're still not sure, test again. Is -6 less than -5? Absolutely. So -6 should be in your solution set right over here. Let's take a look at letter B. I know you were waiting for that with great anticipation. Uh-oh, I must not have been using a ruler. Y is less than or equal to 2. So less than or equal to means that our boundary line will be solid. You can see, if you look closely, I did a dashed line and then had to redraw. Make sure that that's a solid line right at the location where y is equal to -2. Then use our test point, 0, 0. Is 0 less than or equal to 2? Yes, it is. So that should be in your solution set. So here's your vocab for this lesson. A linear inequality is a linear equation that uses less than, greater than, less than or equal to, or greater than or equal to, instead of an equal sign. This is your definition. This stuff you should write down because you need to know it if you want to get these questions right. To graph a linear inequality, you must show two things. First, you have to show the correct type of boundary line. Is it going to be dashed because it's less than or greater than? Or is it going to be a solid because it's less than or equal to or greater than or equal to? You also need to show which side of the boundary line is the solution to the inequality. If you don't have part of that graph shaded in, you do not have a complete answer. So, now that we've figured out how to work with graphing inequalities with one variable, let's come back and take a look at inequalities with two variables. If you've got a y and an x, it's possible that you could look at an ordered pair to see if it fits this inequality. Nothing new here. Ordered pair, x comma y, so plug in x and y where they would go in this inequality, and let's see what happens. Write the inequality, substitute in, notice how they put a little question mark over that greater than sign, because you're testing it out. Is 2 greater than 1 minus 3? And yes, in fact it is. Woohoo! That ordered pair works. 1 comma 2 is a solution. Try it out again on the right side of the page. The second ordered pair they give you is -3, -7. Write the inequality, plug in the numbers they give you, do the math. -7 is not greater than -6, so -3, -7 is not a solution to this inequality. Take a look at Got It number 1 at the bottom of page 390. I'd like you to do both letter A and letter B. B with a question. They want to know if an ordered pair is not a solution of y is greater than x plus 10, does it have to be a solution of y is less than x plus 10? And here's my question. What if y were equal to x plus 10?